Hello, welcome back to my YouTube channel. Massive tutorials. Please do not to subscribe to this channel so that whenever I post any video, you'll be the first to receive it. Alright, we want to look at Mat 103, that's what subsidiary mathematics. And like this, we'll be looking at what elementary what calculus, elementary calculus. Alright, so to proceed, in the elementary calculus, I'm making this for the agribusiness, the agro processing students of the University of Cape Coast. Those who are offering at 103 subsidiary mathematics. Alright, so now we've treated a lot and I want to continue with that. So now, the last time we treated it, quotient rule, quotient rule, treated quotient rule. And I see that if you have a function f of x, which is of the form g over what? V, right? Then, if you want to differentiate this function with respect to what? X, using the quotient rule, then you hold this constant, which is v, right? Then you take the derivative of what? U, so which is u prime, minus you subtract, you hold u, then you take the derivative of what? V, then divided by what? V squared. So this can be written as v du over what? X minus u dv over the x divided by what? V squared. That's what we treated the last time using quotient rule. Now, want to continue with the function of a function. Function of a function. How do we find for the derivative of a function of a function? So let's consider y equals x plus 5 all to the power 3. Here we say that what? Y is a function of what? X. We say that y is a function of x. Because given y, we have it all in terms of what? X. They are all in terms of x. So now, here we have x here, which is x to the power 0. So we are all in terms of what? X. Don't forget. So now, we can say that let u equals what? X plus 5. Right. So if u equals x plus 5, you can get what? Y equals u to the power what? 3. That means wherever you see x plus 5, you can substitute what? U. Is that okay? Wherever you see x plus 5, you can substitute what? U. Now, so we can label this one as equation 1 and this guy as what? Equation 2. So we can say that from equation 1 and 2, we say y is a function of what? U. And u is a function of what? X. From equation 1 and equation 2. Equation 1, u is a function of what? X. And equation 2, y is a function of what? U. The variable u is a link between the two what? Expressions. It's a link between what? The two expressions. So when we substitute x plus 5 into equation 2, we go back to our original question. So how can we differentiate this guy? In order to differentiate a function of a function, then we proceed to what? The chain rule. We use the chain rule. To use a chain rule. Now, to use a chain rule, you have to take roots, right? You have to differentiate y with respect to x, which must be equal to du over what? Dx times the same thing, dy over what? Du. All right. So let's see. Sorry. chain rule, you can apply dy over dx equals what? Du over dx times what? Dy over what? Du. I thought this would cancel that, so I was looking at something else. So dy over x must be equal to du over x times dy over du, which means that you are differentiating the function y with respect to what? X, which must be equal to, you are differentiating u with respect to what? X times you differentiate y with respect to what? U. So let's see. If I have an example as what is given, y equals x plus 5 to the power 3. Right. Want to solve this? You can say that let u be equal to x plus 5. Right. So we can differentiate u with respect to what? X, which will get what? 1. Because if you differentiate x, you get 1, and if you differentiate 5, you get what? 0. Always remember that if you differentiate a constant with respect to x, you get what? 0. Now, let's see again. We can differentiate. So I have my y equals what? This time around, it is u cubed, right? Because wherever I see x plus 5, I can substitute what? U. So I have y equals what? U cubed. So I can get what? Dy over what? Du. So dy over du must be equal to, which means that I'm differentiating this y with respect to u. So I'll get, we use a general power rule. 3 comes down, 3 u, then we subtract 1 from the exponent. So which will obtain 3 u squared. So 3u squared. So now, we've done all these things. So now, we can substitute it into our formula, which is y over the x, which must be equal to du over the x. What is du over the x? Du over the x is 1 times dy over du. Dy over du is what? 3u squared. Right? So now we can say that dy over the x must be equal to 1 times 3u squared is 3u squared. But we can say that u equals what? What is u? X plus 5. So we substitute. So dy over the x equals to 3, x plus 5 all to the power 2. That's it. Very, very simple and very, very trivial as well. Let's see another example, which is example 2, which is y equals x squared minus 3x or exponent 4. So let's see. We can use chain rule. So we can say that what? Let u equal to x squared minus what? 3x. Right? So if u equals x squared minus 3x, we can differentiate u with respect to what? X. I told you that this one is the same thing. So u prime. So we can say that u prime of x, which must be equal to, how do we differentiate that? This one is a sum or difference with u. You can differentiate because here we have what? Differentiate. So we differentiate it what? 10 by what? 10. So we differentiate it what? 10 by what? 10. So we differentiate x squared. When you differentiate x squared, 2 drops down. So I get 2x. We subtract 1 from the exponent. So we get 1. Minus, you have exponent 1 here. So 1 drops down. Then we subtract 1. So we get what? 3 x exponent what? 0. And x exponent 0 is the same thing as what? 1. So I have my du over the x, which is equal to what? U prime of x, which is equal to 2x minus 3. 2x minus 3. Now, we are proceeding. Then we can see that if u equals x squared minus 3x, we can substitute u into that. So I get y equals u exponent 4. Now this, you can differentiate y with respect to what? G. So that we get what? 4 drops down, then you subtract 1. So we get 4 joules cubed. Right. So if you get 4 joule cubed, what again? Then we are done. We come and put all what we've done into our formula, which is dy over dx, which must be equal to u prime of x, which means du over the x. What is du over the x? Which is 2x minus 3. Then times my dy over the g, what is that's 4 joules cubed. So now dy over the x must be equal to, I have 4 joules times 2x minus 3. Where we know that my joule equals x squared minus what? 3x, right? So I get dy over dx, which is equal to 4 times I substitute x squared minus 3x, all to the power what? 3 times 2x minus what? 3. So that is how we differentiate a function of a function. Alright, so let's see this example, okay? Y equals square root of 4x minus what? 3. So now, with this, we can write it as what? 4x minus 3, 4x minus 3, half, right? So we can apply the chain rule here, and we can say that let g equals what? 4x minus what? 3. So now, I can differentiate u with respect to what? X, which is the same thing as u prime of what? X. So let's differentiate 4x. We get so let's see. U prime of x is the same thing as what? The derivative of u with respect to what? X. So we differentiate 4x, we get what? 4. Then we differentiate this negative thing, we get what? 0. So now I have my du over the x, which is equal to 4. Now let's substitute u into that. So we get y equals u exponent half. Right. So now let's differentiate y with respect to what? X. We get half down u to the power half minus what? 1. So we can get half u to the power half minus 1, then we get half. So dy over x is equal to half times this guy. You can take the inverse, which is 1 over u to the power half, and u to the power half is the same thing as 1 over what? Square root of what? G. So we will get dy over the x, which is equal to 1 over 2 square root of g, because we get a multiplication of what? Fraction. And this one is the same thing. We are multiplying. So we have dy over what? The x. Sorry, dy over the g. Y over the g. Y over the g. We are differentiating y with respect to what? G. So now we substitute that into the formula. So I have my dy over the x, which must be equal to what? Du over the x is what? 4 times dy over du is what? 1 over 2 square root of what? U. Where my U is 4x minus what? 3. So we get dy over dx to be equal to 4 times 1 over 2 times square root of what? 4x minus 3. 4x minus 3, which must be equal to multiplication of fraction. We get what? 4 over 2 square root of 4x minus 3. We can cancel out because 2 is multiplying that. So we get that. So my dy over dx must be equal to 2 over square root of 4x minus 3. So that's the third example. So kindly watch it very carefully. So we have a question like this. Y equals what? X squared plus what? 3x or x equals negative 5. Now, if you don't want to use the chain, you can differentiate it straight away without using the chain. Maybe when you get that in the objective test, how can you differentiate it straight away? Just let your negative 5 come down. You get your x squared plus 3x. Then you subtract what? 1 from that. Then times the derivative of the inside. You differentiate the expression inside with the bracket. So if I differentiate x squared, I get 2x plus. If I differentiate 3x, I get 3. So I have negative 5, I get x squared plus 3x. Or x will do negative 6 times into x plus 3. This one can be rearranged as well. I get negative 5 times. I can take the inverse, which is 1 over what? X squared plus 3x all is equal to 6 times 2x plus 3. So we can multiply. This one is over 1. So we get negative 5 times 2x plus 3 or exponent to x squared plus 3x or exponent 6. Right? So this one I can do it and simplify it properly. Negative 5 times 2x we get negative 10x. Negative 5 times 3 we get negative 15 divided by x squared plus 3x or exponent to 6. So you can differentiate it like this if you don't want to go straight by the rule, that's the chain rule or the formula. When it is objectives, you can just go straight like this. I said negative part is like you are differentiating a general rule. Let's say if you have x to the power 4, how do you differentiate? 4 comes down, then times of x to the power 4, we subtract 1, then we get 4x to the power 3. The same thing here, negative 5 will come down, then what? We subtract what? 1 from the exponent. So negative 5 now multiply the expression inside the brackets, and we subtract 1 times the differential of the expression inside it, the bracket. Differentiate the expression inside the bracket. So you get your x squared, and differentiate, you get 2x. When you differentiate 3x, you get your 3. So now, when you get this, you massage it or you simplify it to get the final answer as that. Right. So now, let's apply the chain rule and let's see how we can go by that. Alright, so we are applying the chain. You can say that what? We let u equal to x squared plus what? 3x. What do we do again? We differentiate u with respect to what? X. When we differentiate u with respect to x, we get 2x plus what? 3. Right? Then now, you guys substitute u inside because u represents what? X squared plus what? 3x. Don't forget. So now we have it as y equals what? U exponent of negative what? 5. So if you have y equals u exponent negative 5, we can differentiate what? Y with respect to u. Then we get to negative 5 down, u exponent of negative 5 minus 1. So here we get negative 5 times u exponent of negative 6. Because when you add negative 5 to negative 1, or when you add negative 1 to negative 5, it's the same thing as plus negative 1. When you add these two negative numbers, negative 5 to a negative 1, you obtain what? Negative 6. So I have the y over the x, sorry, the y over the u, which must be equal to, I can rearrange it as for negative 5 times 1 over u exponent 6. So which can be written as for negative 5 over u exponent 6. So we have it as that. So now we substitute that into a nice formula which we have the y over the x, which must be equal to, what is the u over the x? The u over the x is what? 2x plus 3. Then we multiply it by what? The y over the u. We get negative 5 over what? U exponent 6. So we have this. So now, where we can say that our u is what? X squared plus 3x, right? So my dy over the x equals, I have negative 5 over, what is u? X squared plus 3x, all multiplying what? To the power what? 6. All to the power 6. 10 times what? 2x plus 3. This one to the power what? 1. So kindly watch it very carefully. It's not difficult at all. So now, we get dy over the x, which must be equal to then negative 5 times 2x plus 3, or over x squared plus 3x, or exponential 6. So we can multiply dy over the x equals to negative 10x. We multiply this by then negative 15 all about x squared plus 3x, or exponential 6. So you can see that without following the rule, you can do one or two things. If it is objective, you can do one or two things. But if it comes inside a theory, the theoretical aspect of this guys, then chain rule and tell you to apply the chain rule when solving this, then you have to follow the principle of the what? The chain rule to get that. So that's that. Let's see our last example, example 5. So this is our last what example we are doing. That's our last example we are doing here. Our last example. So I said if it is objective, this is how you go by it. 9 will drop off. Then use it to multiply the expression inside the bracket. What do? You subtract 1. Then you times, you differentiate the expression inside the bracket. When you differentiate 3x, you get what? 3. When you differentiate negative 9, is what? 7. Because it's a constant. Now we get 9, 3x minus 9, then 8 times 3. You can see that this 3 can multiply what? 9. So 3, 9, or 9, we get 27 times what? 9, 3x minus 9, all exponent to what? 8, all exponent 8. So we have this. So now, let's apply the chain rule and let's see how it goes. Alright, so let's see. Let's apply the chain. What do you do? You start by saying that well, let u equals to 3x minus what? 9. Then what do you do again? You differentiate u with respect to what? X. So when you differentiate u with respect to x, this one you have x there here, so you can differentiate. So here is to the power 1, it multiplies, you get 3, subtract 1 to 0. X to the power 0 is 1. So 1 times this thing is the same thing. This one is a constant. We don't know it. So it's a constant. So it tends to it 0. So we get u over the x equals 3. Then now, I have it as y equals, because I know that my u is 3x minus 9. So we substitute u to the power 9. Follow it very, very carefully. So now, let's proceed. I have y equals u exponent 9. We can differentiate y with respect to u. Very simple. 9 drops down. We subtract it 1 from the exponent. So we get 9 root exponent of 8. So we have our dy over du to the 9 root to the power of 8. So now we apply the formula here, which is dy over dx must be equal to what is du over dx? Du over dx is 3. Multiplying dy over du is what? 9 root to the power of 8. We can multiply dy over dx equals 3. Now we get to 7. U exponent with 8. Now, where my u equals what? 3x minus what? 9. We substitute. So dy over x equals 27 times what? 3x minus 9 or x minus 8. So that's it. Very, very simple, very trivial as well. So let me give you examples to go and try it yourself. Alright, so that's a try work. We have y equals what? Square root of 9x minus 2 or exponent negative 3, y equals x squared plus 1 by x or exponent 3, y equals x squared minus 9 by x or exponent negative 4. Where mathematics literacy begins, master tutorials. Please do well to subscribe to this channel. Thank you for watching. If you have any comment, kindly drop it at the comment section. Thank you and have a nice day. Kindly watch it. Subsidiary mathematics math 103. We are doing elementary calculus, a function of a function. Now when we meet next time, we proceed with what? Combination of product, quotient, and what? Chain roots. Then we proceed with implicit differentiation. So gradually, we come to an end of this lovely